Hello learners, today we are going to see about distraction of a driver or whether he is having a normal driving. So this will be like a model training by using a machine learning. So the list of training will be provided: normal driving, texting using right hand, using mobile on right hand, so texting using left hand, or drinking, hairstyle, and makeup. So these are all the distraction. So normal driving and distractions. Some 1500 images for every classes will be provided, and it has been trained. So this will be like displaying. So we can have a input as image or a direct feed from a webcam of a laptop. So if it is a direct feeding, it will be a live. Or like you can just place it in front of a car and you can just see whether the person is driving, texting. Using mobiles means like speaking with phone by having mobile phone in left or right hand, or like making a hair makeup or something like this. So you can just give a image, input image, so that the model is going to just predict whether the person is normal driving or whether he is using the mobile phone on right hand. So like this, some several images you can just test with, and the model is giving a accurate results. So this was like how to see the output. So one can understand the things like so you can just see normal driving, mobile phones using text or speaking or something like this. So this is a code. At the very first line, we will be having loading the model which have been trained earlier. So model designing will be like having convolution layers, max pooling layers, normalization layers. So I can just show you the model. So this was one of a website called Netron. The saved model can be uploaded here so that you can just see how exactly the model have been trained. So the input image of dimension 224 cross 224 rows and columns, and 3 indicates that it is a color image. So the first layer is convolutional 2D layer. So it will be like which is this layer is going to reduce this dimension to the lower levels. So it will be having kernel size 3 cross 3 and the number of filters. So 16 filters. So like this, the convolution layer will be present, and the next one will be like normalization and pooling layer will be present. So this ReLU is an activation function. So normalization is the one which is going to make the image in a definite range. So padding is going to happen whenever the sliding window is going to happen. What I have been just telling about 3 cross 3. So our image is 224 cross 224. Out of the 224 cross 224, every 3 cross 3 images will be taken. See, consider if this is our 2 cross 224 cross 224. So starting from, so like this. So this is an example I am just taking with. So if our kernel window is 3 cross 3, first thing will be like it is going to take the, what is this, the pixel value. So the number here will be the pixel values. So it is going to take the pixel values and it is going to have a filtering mechanism. So consider like I will be just showing the 3 kernel movements. So this is our first kernel. So if this is our first kernel, so the filter coefficients will be like this. For one of a filter, I am just example sake, I am just saying this will be not same as this one. So these numbers will be multiplied 1 into 1. So it will be imposing on it. So these are all the pixel value. These are all the filter coefficients. And these here, what we are seeing, these are all the pixel value. Take filter coefficient. So this filter coefficients will be overlapped and it is going to be added and it is going to give the results. So this will be the for the first kernel. For the next kernel, it will not jump to next three things. It is going to take these rows and columns. So this is for second one. And in the same manner, the next thing will be like for this one. And for the next thing, this. And for the next row, again, only the window will be go on moving. So in this manner, the convolution layer is going to reduce the things. So this batch normalization is going to make all the values to selected range. So like this is the model which have been designed. So this one the thing what the model designing actually means that. So in order to have this kernel addition model dot keras dot add layer, you can add a convolution 2D and you can give the number of filters, input size and all. So once model has been just trained, so our job is to load it and feed the labels. So these are all the labels starting from 0 to 6, like 7 classes, normal driving to makeup. And this is like converting the input image to the model trained sizes. So we have been trained for 224 cross 224 into 3. So this is a input dimension here. So that will be sized and it is in the data type of float. And everything will be converted into a rows, only a single row value. So all these things 224 cross 224 into 3, that will be just converted into single row 1 cross, so single row 224 cross 224 into 3. So these many pixels will be entering here. So this is the image size that will be sitting in a matrix called data. So we are going to convert this image into RGB. So and the size is like 224 cross 224. Resample it and make it as a array. So this array is going to be normalized and sitting in a data. So we are pushing model.predict. Model have been just loaded in a previous thing dot predict of data. And we are pushing the index to the prediction and we are going to predict and the predicted value will be printed. So for taking an image, matplotlib as printing an image. So we are going to add text to it, read the image, we are going to subplot it, and this is like put the text where you are going to put the text on the image, shown image. So these are all the bold font size and all, and the color of that text should be red. So like of that red color, we are going to give some rectangle of some width and all. And we are taking an image, pushing the class name which have been coming from a prediction, and we are just printing on it. And you can just print the confidence score as well. So confidence score actually means that this image is resembling to the normal driving with the confidence of 99% by model. So model is 99% confident that this image is a normal driving. So that is called as an confidence value. So that's it for this video, guys. I guess you have got some of inner information on how to design a model, load it, and have a prediction of normal driving versus distracted persons. That's it for this video. Thank you.